This is mine and Arya's video on System Omega boards.
Hello, we are Karthika and Arya, and we're going to show you the System Omega boards and a little introduction to each of them. So yeah, there are 3 boards. There's the inputs, the processes, and the outputs. We'll start off with the inputs. There's a temperature sensor, which of course you have to touch it, and then that makes the light go on. The external sensors, and we're not really sure how to use that yet. The sound sensors, which will always be on because there's always sound coming towards it. The moisture detector, where you put a little bit of liquid on it and then it goes on. The light, it'll always be on again because the light is always shining on it, but you can cover it to make the light go off. A push switch, which is quite explanatory, where you just switch it on. The two-way switch, where you just switch it the 2 ways. The reed switch, where the 2 metals have to link to make that go on. And the pulses, again, we're not really sure how to use that. To make this go on, and we'll show you how to connect it later on, but we just switch that and then on. Yeah, on. And then the lights go on. So again, the temperature, you just press it and it goes on. Push switch.
And there are processes. We have the AND, the NAND, the OR, the NOT, the NOR, another NOR, a delay, and a debounce. The AND means both inputs have to be on for the output to work. The OR means one input or both have to be on for the output to work. The NOT means the input has to be, if the input's on, the output would be off, and vice versa. NAND means both inputs have to be off for the output to be on, and vice versa. The NOR means one of the inputs have to be on for the output to be off, or both of them. The delay keeps something on for a fixed period of time. If you turn the knob clockwise, you will decrease the amount of time that it's turned on for. It's especially good for short-lasting inputs such as the sound sensor. The debounce stops 2 metal surfaces, like the reed, from bouncing apart when they make contact.
Then lastly, we have the outputs board, and the bulb when the switch goes in it, and when everything's connected, the bulb goes on. The motor just keeps spinning round and round. For this one, we can make the motor go forwards and backwards. The relay, it just keeps ticking, goes between each of them. For the sounds, of course, it makes sounds. The melody just makes a really nice melody. The siren is like a siren, the police like the police, and the beat too. Then lastly, for the counter, we have the LEDs. They go on like one by one. That's it.
So we don't always need the processes board, so for our next project we're going to take it off.
So yeah, and the project we're doing is in the babysitting category, and that's the baby's crying. So for this we make a device which will turn on the light, play a tune in the room, and also sound an alarm downstairs when the baby cries. And for addition, we're actually going to make the cradle rock too. So yeah, we don't need processing. We're going to use the first things to connect it over here. We're going to use these connectors and the wires here to connect them, so we're going to use these small ones. Put together.
We recommend you use the small ones.
Yeah, they're much better than the big ones. And there we go. Okay. Then we're going to take these wires and but because the sound sensor will always be on, we're actually going to use the light sensors, and we're going to use the light sensors. So we're going to connect this to either one of them, and we're just going to do it to the wall. As you can see, it goes on. Put that out of the way. Okay, and then we're going to connect it to here, and a wire to it. And we're going to make it go to either one of the next ones. So, the melody. Let's just go with the melody. And then, again, we're going to take another one, connect it to the exact same one, and make that go to either the siren. If you can hear, it's actually on when we do that. So, okay. Oh my god.
As you see, it gets loose.
And it does get pretty mad sometimes. And lastly, we just connect all of them together with doing that, and we'll just add the last one, which is the motor. Oops. Actually need some help holding it here. And yes, it does get loose.
It's just loose. It's supposed to work.
Yeah, it is. We've tried it before, like a million of times. It's just that it's just loose. And yeah, it's actually supposed to work. It's because of this. Okay. And yeah, you actually can see that. It's all weird. And yeah, but it's supposed to work like that. I hope it works now. Yay! All of them are working.
This project, we are using the processes, so yay. And the project we're going to do is called Entertain the Caller.
Oh, entertain the caller. Yeah.
It's when we try to put a switch, so if the caller comes up, a switch, and then the melody or the sound turns on, even though you let go of the push switch till the end. So it's sort of like a loop, but it doesn't keep going on and on. So we'll start by putting the wire to the OR, to the push switch, and then we will put this wire to the OR, and then lastly we'll put this wire to the melody. Okay, now let's give it a go. See, it's working! And my hand is off it. It's not there.
Yay. That's the sweet melody. Yay.
So,
Now is the time for advice, if you haven't done this yet.
so make sure these wires are on, because we had to do our project all over again because these were loose and we thought there was something wrong with our actual circuit wiring. So make sure these are always put together and make sure this is always turned on.
And the wires are annoying, so like that just went off now, right now. Yes, they are annoying. And for the project, start with easy so that you kind of understand how to use the boards, and then start off with hard ones.
And the components, these outputs, they don't always work. And if you put one on, maybe a different one works. So you have to keep trying until you get it right. So,
Like for this one, we actually, instead of putting it to the motor, we actually put it for the forward and reverse. And then we were wondering, why is it all going wrong? So yeah, thank you.